Welcome back to the Siemens TIA Portal tutorial. In episode 5, we introduced one of the useful PLC tools, timers. You learned how T-on, T-off, and TP work, and we even used them to control simple delays and pulses. Now in episode 6, we are going to use timers to make a flasher and also add stack lights into our project. These colorful towers sit on top of almost every industrial machine, giving operators and maintenance staff instant feedback about what's happening. Imagine walking through a factory. You don't have time to check PLC screens or HMIs for every machine. Instead, you glance at the stack light. Here is how we will define our stack light logic. Red is emergency stop, yellow is motor or VFD fault, flashing blue is filling in progress, and green means conveyor is running. This is the PLC Beginner Mega-Project playlist. We're building a complete packaging line step by step, learning timers, counters, alarms, and HMI along the way. If you're enjoying the playlist, please support the channel by liking the video and subscribing. Your support really helps me create more content like this. Okay, let's do the programming. We go back to OB1. Here, we need to define a couple of signals. I go back to main I/O signal list. So here we have green lamp and red lamp signals. We need to add 2 more. So I add yellow lamp for warning. The address is Q0.4, which is okay. Doesn't really matter, we are just doing the simulation. I also add blue lamp here, and that is going to be Q0.5. So we have all 4 lamps for our stack light. Okay. So here, first of all, on the first network where you basically start and stop the conveyor motor, here we want to have our green light to be turned on when the motor is actually started. So I'm going to add a coil on the output of this flip-flop, and I assign it to green lamp. Just as simple as that. So as soon as you start the motor, that green lamp will be turned on and vice versa. Now let's add this network for blue lamp. As I mentioned earlier, this is going to be a flashing light, and we are going to use this conveyor stop signal in our flasher logic. Okay, for our flasher we basically need 2 T-on timer. So I go to the instruction, timer operations, and drag and drop our first timer. Here again you need to assign an instant or data block. I name it flasher on. Okay. As I mentioned, we need 2 timers, so I add a second branch and bring in the second timer and just name the data block. I name it flasher off, and awesome. Okay, I add another branch here, and we add a normally open contact. Here we need to use this signal, conveyor stop, in our flasher logic as I mentioned. So I just copy and paste it here. Okay, We need to define an internal memory. I name it time delay beat. So on the input of the second logic, I add a normally open contact and I assign it to the internal memory that we just created, time delay bit. And the output of our timer is going to be a coil, and we need to have a reset here. And I assign it again to time delay bit. So on this branch, we add a normally closed contact and we use this bit there. And the output is going to be our blue lamp. Our flasher is not yet complete. We still need to define the input of our first timer. So that's going to be a normally open contact, and I just assign it to the blue lamp, and the output is going to be time delay beat, and this time we set this signal. Okay, so now the last thing that we are about to do is to just assign the times to these two timers. The time for both can be 500 milliseconds, or it can be 1 second, or whatever you desire to set. Basically, with these two timers, we control the on and off periods of the timer, and you can basically choose different times to make your flasher faster or slower based on the application that you have. So lastly, we add a line of code for our red lamp, and as we mentioned earlier, the emergency stop signal will turn on the red lamp. And now the last lamp that we need to add into our program is a yellow lamp. So just let me add another signal here, motor fault, and this is going to be I 0.4. It can be a VFD fault, and I add a normally open contact and assign it to motor fault, and the output is going to be our yellow lamp. Awesome. That's everything that we need for our stack light. I save the project and download to the simulator. Okay, here is the simulator. Let me add again the signals that we need for the simulation. I added all the outputs here so we can monitor their status. Awesome. Okay, so the motor is started. As you see, the conveyor is running and the green lamp is on. It's exactly as we expected. Now if I activate the emergency stop, you see now it's off, and when I activate the emergency stop, the conveyor is stopped, the green lamp is off, and the red lamp is on. And when there is no emergency stop, the red lamp is off. Again, I stop the conveyor, green lamp is on and the motor is running. Okay, now let's test the flasher. The idea is if we activate the bottle sensor, the flasher should start flashing, and as you see, the blue lamp is flashing here. That actually flashes for the whole filling period, and as soon as the filling period is over, the blue lamp turns off. So I activate it again. It's filling process, and there is an indication for the operator and everyone on site to see that the filling is in progress. And as soon as the filling is over, the blue lamp turns off. And for the whole period that the conveyor is on, we have the green light on. And when the filling process starts, the conveyor stops, the green lamp turns off, and the only lamp is actually blue lamp, which is flashing. Let's quickly check the yellow lamp as well. And as you see, when there is a VF default, the yellow lamp, which is for warning, turns on. The VF default does not stop the conveyor, that's only warning. In real factories, the stack lights are not just cosmetic, they are part of safety and productivity. Priority matters. Red always overrides green. If a machine is in a stop, it must never look like it's still running. Now our packaging line communicates the state clearly. Try implementing this logic in your test environment, and also try adjusting the blue lamp's flashing speed. You can make it faster or slower, and also add a flashing mode for the red lamp, so e-stop isn't just steady. If you like this video, give it a thumbs up and subscribe to follow the playlist, and see you in the next one.